So we're gonna have a test tomorrow. So what is a Newton equal to? What are the units that Newton are equal to? Yeah, Newton's is force. What's the equation for force? So what are the units of mass? M. The kilogram. So it'd be kilograms times, and what are units for acceleration? Squared. Yes. So the units of Newton is kilogram meters per second squared. What is the definition of mass? What is mass? The weight of something is a force. Weight is equal to a force. What is mass? Mass is a measure of what? How much matter something has. And Michael, put on your mask. So, what is that force that pulls you down to the ground? Called gravity. What's some examples of friction? I mean, what are the types of friction that we covered in class? We had static friction, sliding friction. What's another one? Oh, we had rolling friction, static friction, sliding friction. We had air friction. We usually don't call it air friction. We usually call it air resistance. That's a type of fluid friction. So air resistance is one. So what's inertia? Property of mass. The greater the mass is, the greater the inertia. So everything, inertia is a property that tends to make you stay at rest. So it resists change in motion. So. Excuse me, teachers, we are going under a soft lockdown at this time. Close the door. Keep kids in your classroom. No one is to go out of the classroom for any reason. Soft lockdown at this time. So inertia is the property of resisting change in motion. So if a car is rolling down a hill, or if a car is moving, it's going to resist changing its speed. So if you were to stand in front of a moving car, it's probably not going to slow down too much after it hits you. That's because of its mass, because of its inertia. So if I were to punch a wall, why would you hurt your hand? Because the wall does what in return? So if you apply a force on a wall with your fist, third law, which states the wall is going to do what to your fist? Equal and opposite force back onto your hand. So it will exert an equal force but in opposite direction back on your hand. So what is the equation for momentum? Mass times velocity. So how can you increase momentum? So increase your speed or mass. Again, weight is force. So, let me actually show you guys a video.
This is NASA's Space Power Facility near Cleveland, Ohio, and it is the world's
I'm recording, so my computer is out of RAM.
biggest vacuum chamber. It's used to test spacecraft in the conditions of outer space, and it does
So
that
this is the
by
world's
pumping
largest
out
vacuum
30
chamber.
tons of air in this chamber until there are about 2 grams left. And it's
So
a heavy object
here's a
and a light
feather and a
one,
bowling ball.
and drop them at the same time to see which fell fastest.
So we can see the feathers are being slowed down by air resistance. Air resistance is keeping them from making them glide back and forth. Now this
So
is
in
the
this
world's
case,
largest vacuum chamber. What would happen if we closed it up and then pulled out all the air in the room? No. Is there still gravity? Yes,
it
all
takes
the
3
air will be
hours to pump
removed.
out the 800
Yeah, gravity will still work in a vacuum.
1, 2, 1.
So
Release.
watch this. So here they're dropping them in a vacuum. They're falling down because of gravity. No, it slowed down. It's slowed it down in slow motion. But the feather and the bowling ball now drop at the exact same rate. So objects accelerate down to the Earth with the same acceleration.
Look at that.
The only reason a piece of paper doesn't fall the same as a rock or a calculator when y'all drop on the floor, making me cringe every time I see it. They would both fall at the same rate if it wasn't for air resistance. So on Earth, a feather and a bowling ball usually won't drop at the same rate because of air resistance. Air resistance will push up on the feathers. But if you were on the moon, and let me see if I can actually find that video. So, feather drop, moon.
Jim, we copied both solar wind and penetrometer drum in the ETB.
Not quite yet. I haven't put
So
the
he has a
solar in
hammer.
yet, but I will shortly. I want to
So he has a hammer and a
watch this.
feather.
You have a good picture there. I've got
Beautiful picture, Dave.
well, in my left hand I have a feather. In my right hand a hammer. And I guess one of the reasons we got here today was because of a gentleman named Galileo a long time ago who made a rather significant discovery about falling objects in gravity fields. And we thought that where would be a better place to confirm his findings than on the moon. And so we thought we'd try it here for you. The feather happens to be appropriately a Falcon feather for our
They
Falcon.
launched on a Falcon
And
rocket.
I'll drop the two of them here, and hopefully they'll hit the ground at the same time. How about that?
He doesn't even look down. He just knew it was
Mr.
going to happen.
Galileo was correct in his findings.
I like how he obviously can't look down in the space suit. So he's like, how about that? It worked. And then it hits the ground. It's like, well, obviously confirmed. Wouldn't it be like amazing if the video showed it not working for some reason? But so you might notice it'd be hard to tell, but you might notice that it drops ever so slightly slower because the acceleration of gravity on the moon is less than the acceleration of gravity on the Earth. So if you were to drop a hammer and a feather on the moon, it'd fall at the same rate because there's no air on the moon. So I said air resistance, and that's y'all said it, it's a type of friction. What type of friction is it exactly? Fluid. Air is a fluid. Yes. And put your mask on, Michael. And you too, Thomas. So, what is the law state? What's the first law state? An object at rest stays at rest unless acted upon by unbalanced force. What's the second law state? The second one, I remember it as F equals ma. You could go out and say the acceleration is directly proportional to mass and inversely proportional to acceleration. So, inversely proportional to mass. So acceleration is directly proportional to force and inversely proportional to mass. So A equals F divided by M. However, I just memorized this F equals ma. Newton's third law states, for every action, there's an equal and opposite reaction. Another way of stating it is if one object exerts a force on another object, that other object will exert an equal but opposite force back on the original object. So if one object exerts a force on another, that other one is going to exert a force backwards onto the original. So if you have a baseball sitting still, or I should say if you take a bat and you hit it to the ground, you'll see the bat bounce back up. You exert a force onto the ground's going to exert a force back on the baseball. So that force exerted by the second object is going to be equal but opposite in direction. So equal in size or magnitude, but opposite in direction. Why does a person in water when swimming move forward? So if you're swimming in water, how are you able to swim forward? Because you're pushing against the water then pushes back on you. So if you push water backwards, water is going to push you forwards. So which law deals with inertia? First one. The first law is actually called the law of inertia or Newton's first law of motion. Both of those are the same name for the first law of motion. So the two major equations you got to memorize is F equals ma and P equals mv. So which would have more momentum? A small rock rolling down a hill or a large boulder rolling down a hill? Assuming they have the same speed, then the one with the more mass has more momentum. And I said momentum is also very similar to inertia. So, for example, if you had a toy truck and someone pushed it towards you, and then if someone took a four-wheeler and also pushed it at the same speed as a toy truck, which would be easier to stop? The toy truck, because it has because its momentum will be less, or because it has less mass. A bullet. Can a bullet have more momentum than a large truck? Yes. So again, its momentum is mass times velocity. So if your velocity is really high, it means you have a high momentum too. That's the reason why it's very hard to stop a moving bullet. Not because of its mass, but because of its velocity. So, which do you think would be going faster? Which one do you think would have more momentum? A dog running at 10 meters per second, or a human running at 5 meters per second? Wait, let me, so, a small chihuahua. I did, so yes. Alright. So a small chihuahua running at 10 meters per second, or an average adult male running at 5 meters per second. Yes, because so he's traveling at half the speed as a dog, but the mass is way more than double. So the more than double would cause him to do it. Yeah. Whenever I say a person, generally what I mean by that you can think of is an average adult male. That's usually what in physics, if you look up like the surface area of a human, it'll actually say in the description, the surface area of an average adult male is this, because it varies based on whether or not you're a kid versus an adult. And then we also take average, and usually they select male over female whenever they do measurements. So know how to solve problems related to F equals ma. So if I said that the mass of something was 10 kilograms and the force was 20 newtons, what would be the acceleration? 2 meters per second squared. So know how to solve. Remember, you can write that triangle. By the way, for the remote learners, there is code word. So, if you have something in the form of A equals B times C, you can draw a triangle and look at B times C. So we know that this is going to be our multiplication symbol. So if it's B times C, we can put in here B times C, and the term remaining over would be A. If we have an equation, D is equal to E divided by F. There's a division, this over that. What you can do to make your triangle is we know it's going to be E over F, so I can put in E over F. So E is our F, and what's remaining is the letter D. So if you needed help on drawing triangles to solve it, this is how you do it. If you have multiplication, it's going to use the multiplication here. If you have division, it's this over that, so you'd put this over that. And then solving, so for example, if you wanted to solve for E, E is just D times F. Or if you wanted to solve for C, C would then be A over B. That is how the triangles work. So there are 30 questions on the test. The first 19 are word problems similar to what I just said. So definitions and such. The last 11 questions are going to be pure math. About pure math. I see one of them not. So about 10 questions that'll be math. The momentum problems. So if I give you, so if you see kilogram meters per second, that means it's momentum. If you see kilogram meters per second squared, that's newtons. If you see newtons, that's if you see kilogram meters per second squared, that's newtons, which is force. Or if you see newtons, that's also force. If you just see meters per second, that's velocity. If you see meters per second squared, that's acceleration. I'll actually go ahead and write that. So remember, kilograms is mass. Meters per second is velocity. Meters per second squared is acceleration. Kilogram meters per second is momentum. And kilogram meters per second squared is force. And newtons is also force. Note these two are the same thing. So we deal with a lot of units in this class, and they all mean different things. And they're all going to be combinations of kilograms, meters, and seconds. I could also add up here, meter, M is for meter, and S is for seconds. So really all the units in this class are going to be based just on these three. Sometimes I will, when they start getting long and complicated, tell you another unit for it. For example, in the future, I'm going to be doing joule. You don't need to know this now. Yes, that is a unit of energy. So a joule, again, you don't need to know this now, but a joule uses the letter J, capital J, and it would be equal to a kilogram times a meter squared over second squared. And because this is getting quite long, basically after momentum, the units start getting very long, and what we start doing is just renaming them to something else. So after momentum, we start renaming all these long variables and something else. So once we add another second to this, it becomes newtons. If we take force and add another meter to it, it's equal to joules. Again, you don't need to know about joules now. That'll be next unit. So any questions on the test? So the test is going to be tomorrow. It'll be 30 questions long. And it'll be due at the end of class, meaning if you don't finish, you don't finish. Oh, I lied. I just realized there's another page. There's 34 questions on the test. This was a quiz, but if you weren't here yesterday, you can take it home. Just turn it in tomorrow. This equation here. Do y'all remember it? And G is equal to a constant 6.674 times 10 to the negative 11 Newton meter squared per kilogram squared. I will give you this on the test. It is not multiple choice. These last 4 questions. So 31 to 34. But basically the last 4 questions requires you to plug this into a calculator and just see what it equals. So I'll tell you that one object has a mass of 50, another object has a mass of 20, their distance between them. I'll also give you that Earth's mass is equal to 5.9722 times 10 to the 24 kilograms. And so this is the mass of the Earth. And then the radius of the Earth is equal to 6.378 times 10 to the 6 meters. And basically, you just have to plug in the calculator and write down what you get. But you don't have to memorize the equation. I'll give you the equation and values. So if there's no questions, that's it for today. Oh. Nicole, I need you to do something for me. Put your mask on. Go fill this up with ice for me from the cafeteria. Yes. Oh, yeah. No, I forgot. I sent her on. It's important that she leaves. Y'all make sure y'all have y'all's mask on. I'm standing here ready to close it at a moment's notice. Hopefully they lift it soon. I forgot we are under a soft lockdown. It was too late to stop. You were already gone by the time Under Stewart reminded me. Thank you. Hopefully it ends before next period because this is chemistry experiment. From floating cans.